let's take a look at the first three trigonometric ratios, okay? First of all, let's take a look at a right triangle. Here's a right triangle with an acute angle of theta right here. This is my acute angle. Remember, acute means an angle less than 90 degrees. All right, so what I'm going to do is I'm going to label my three sides of this triangle in relation to our angle theta. So what we'll do, we'll call this side the side opposite theta. Okay? So this is theta. This will be the side opposite. We'll call this side the adjacent side. And I'll just abbreviate it, adjacent. And the side that's opposite the right angle will always be known as the hypotenuse. So I'll abbreviate that HYP. Now, if this was theta up here, this would be the opposite side, and this would be the adjacent side. So notice, I can take any pair of sides and create a ratio. I can take opposite over hypotenuse, hypotenuse over opposite, opposite over adjacent, adjacent over opposite, etc. Okay? So what I'd like to do right now is define the first three ratios. And here they are. And be sure to write these down. Given a right triangle with an acute angle theta, we define the following trigonometric ratios as follows. Sine theta will be known as the ratio of the opposite side over the hypotenuse. Cosine of theta will be defined as the adjacent side over the hypotenuse. And the tangent of theta will be known as the opposite over adjacent. Now let's see how this works. And I'll show you a little trick to memorizing those in a moment. So here is a right triangle. Here's my acute angle theta. It says find the following. Let's find the sine of theta, the cosine of theta, and the tangent of theta. So let me go ahead and write those here. All these things are is just ratios of two of the sides. We just have to write the correct ratios. So let's go back to our definitions. Sine of theta is the ratio of the opposite side over the hypotenuse. Okay? So sine of theta must be the opposite side, which is 5, over the hypotenuse, which is 13. So the sine of theta is 5 over 13. Nothing to it. Cosine we define as the adjacent side divided by the hypotenuse. So here's theta. The adjacent side is 12. The hypotenuse is 13. So cosine of theta is 12 thirteenths. And finally, we define tangent of theta as the ratio of the opposite side over adjacent. So the opposite side is 5. The adjacent side is 12. Now you might notice that we could define three other trigonometric ratios, and we'll do that in the next lecture. But let's try to figure out how we're going to memorize these things, and that's the important thing, is that you know exactly which sides that we need to put on top and on bottom. So here's a nice little trick. This is a trick that I learned, and I've never forgotten it. It's kind of silly, but it will help you memorize it. If you can memorize this little saying, okay, you will be able to memorize the ratios. Write this down in your notes. Some old horse caught another horse, taking oats away. Now all we have to do is look at the first letter in each word, and we can write our trig ratios. So some old horse, sine is equal to opposite over hypotenuse. Caught another horse, cosine is equal to adjacent over hypotenuse. Taking oats away, tangent is opposite over adjacent. Some of you may have seen this before. Soka-toa, it's just the same thing. Okay, so if you want to memorize this little saying, some old horse caught another horse, taking oats away, you've got it. Or if you're accustomed to Soka-toa, okay, sine, opposite hypotenuse, cosine, adjacent hypotenuse, tangent, opposite adjacent, that's fine too. But you've got to memorize these somehow. And this is just a nice little silly way to memorize it. Okay? All right, let's do one more problem. Here is a right triangle with angle A, angle B, and angle C. C is my right angle. It says find sine of A, cosine of A, tangent of A. All right, notice I only have two sides. Okay? So I have to first figure out what this missing side is here. Well, usually if I'm giving an angle of capital A, my side I'll denote it as little a. So let's try to figure out what little a is first. We need all three sides before we can find the ratios. Well, we do know the Pythagorean theorem says that a squared plus b squared is equal to c squared. So I'll go ahead and write that down. A squared plus b squared is equal to c squared. And I'll just solve for a. A squared plus 9 is equal to 49. So a squared is equal to 40. If I take square roots, a is equal to square root 40. And we could probably reduce that. Let's see, square root of 40 is 4 times 10. And the square root of 4 is 2. So our side A is 2 square root 10. Okay, so we did that just by the Pythagorean theorem, and you're used to doing that. All right, so now I've got all three sides, and I want to find the sine of angle A, cosine of angle A, and tangent of angle A. Let's go through our little saying first. Sine of A is what? Well, some old horse, right? Sine is opposite over hypotenuse, so opposite is 2 root 10. Hypotenuse is 7. Cosine, remember, some old horse caught another horse, so cosine is equal to adjacent over hypotenuse. So the adjacent is 3. Hypotenuse is 7. And finally, tangent. Some old horse caught another horse, taking oats away. Tangent is opposite over adjacent. And I've done it. Okay? So I think it's very important that you memorize the definition somehow. And this is just a way to do it. Okay? Write this down somewhere in your notes. And by all means, write down the definitions here of sine, cosine, and tangent. In the next lecture, we'll do cosecant, secant, and cotangent, which are just going to be reciprocals of the first three.